Alright, here's how our VOR works. Literally how it works. It's quite ingenious. I kind of think I wish I had invented it, because then I'd be rich, right? Alright, so here's how we explain a VOR. We're going to pretend we're looking at a lighthouse. I'm looking at it from the top. Okay? A lighthouse has the rotating light that goes around. Right? So me and Bud, we go out to his grandpa's place, you know, because his grandpa owns a lighthouse. Everybody's grandpa owns a lighthouse in Cessna, right? So we go out there and we're looking at this lighthouse sitting out there on this island, just watching that white light rotating around. Look out, and there's a ship stuck in the mud. I was like, man, what happened there? Oh, there's this big old bar of sand out there you get stuck in. And I said, well, it wouldn't be cool if we could like use the lighthouse to tell them where that bar of sand is. So we started thinking about it, and we decided, hey, we got an idea. So what we do is we take this big yellow strobe light and we install it on top of that lighthouse. And we hook up a switch so that every time the rotating beacon points north, the yellow light flashes. Then we time how long it takes the white light to go all the way around, and we find out it takes it 12 seconds. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we decide, all right, this works out pretty good. All we got to do now is every time I see the yellow light flash, I'm going to start a timer, and then as soon as I see the white light flash, I'm going to stop the timer. 1 second is going to equal 030, 060, 090, and on and on and on around the compass. Pretty easy? Anybody not understand that? So now I can actually look at this lighthouse and time and see exactly where I am in reference to the lighthouse. The VOR works exactly like this. Exactly. Except that it rotates at 1800 revolutions per minute and is timing the speed of light. So it works just a little bit faster than my stopwatch. But it works exactly the same way as this. It sends out one signal in all directions with then a rotating antenna. The old systems actually had a rotating antenna in them. The new systems they've digitalized. The comparison I make is Grandpa got sick of going up there and oiling this rotating beacon, so he decided to install 360 LEDs that just sequence and go digitalize. So there's no moving parts in them anymore. Question?
So you said it rotates at 100 revolutions per minute?
1800 revolutions per minute. So when you listen, when you go to ID the VOR, and you hear that in the background, all that is that signal hitting you 1800 times per second. That's what you're listening to when you can hear that awesome, horrible sound, whatever that is.
Wait, you said per minute or per second?
Per minute.
Per minute.
1800 per minute.
So,
And if you calculate it out, that's because of, anyway, speed of light. Go ahead.
I was going to ask about the light again. So, what you're saying it's like a white light, yellow light. Explain that part again, just how it's timing it out.
Okay, so I installed this strobe light on top of here. Strobe light, you can see it everywhere, right? It flashes, and you can see it, I can see it, yeah. So everybody can see that strobe light. Well, we hook up the switch so that this flashes whenever this one points north, the white light. So if I was standing directly north of the lighthouse, I would see the rotating white light flash and the yellow light flash at the same time. And I would know that I'm north of the station. If I was over here, though, I would see the yellow light flash, and 3 seconds later, I would see the rotating light flash.
You just take the difference.
Yep. And so I'm just timing the difference, because I know that it takes it 12 seconds to go all the way around, and so each second I've just assigned to a radial, or to an actual direction. And so literally that's how it works. I'm just timing. So literally what it is, okay, so now we can hand this out to all the sailors so that they don't hit that stupid mud barge anymore. And we give them a little chart that just says, all right, 1 second equals 030, 2 seconds equals 060. Well, that's basically what the VOR is pre-programmed with. The VOR receiver is pre-programmed with how many seconds equals what radial. Now obviously they're timing it in probably billionths of a second, because they're timing the speed of light. Okay, But it's nonetheless, that's exactly how it works. It receives the timing, looks it up on the chart, and says, all right, this is what radial I'm on. So when I turn the actual knob on a VOR, am I actually tuning in anything?
It's changing the timing or something.
It's not changing anything.
You're just saying, hey, I want 7 seconds. Tell me where it's at.
So basically, all you're doing is saying, it knows what radial you're on. Your VOR receiver always knows what radial you are on. So therefore, if it knows I'm here, and I tune in 090, it's going to tell me that 090 is off to the north by more than 10 degrees. Because it knows where I am, and so therefore it knows where those other radials are in reference to me. Makes sense? Kind of. Yes. Okay. So, that's the basics of how it works. Understanding that leads into why is that important to me? If you ever don't think something's important, challenge me and I'll tell you why, okay?
Holding your breath for 9 minutes? Yes,
Okay, to from indicators. What are they? How do they work? What do they tell me?
Tell you whether you're going towards the station or away from the station.
All right. So, turn my VOR. To from indicator will flip when?
Station crossing.
Say I'm flying from here to here.
When you turn the VOR,
I'm not even going to cross the VOR.
Station passing.
would be radial passage. And what radial you have to get in when you.
So,
You have to cross that line.
90
Visor,
degrees to
yeah.
the radial that I've got tuned in. So if I have this radial tuned in, I'm going to get a to from flip right there. Okay. So 90 degrees from is when I'm going to get the flip, okay? So what it tells me is, when I give it a certain heading, we just arbitrarily tune something in. So in this situation, we do, what do we have? A 2 indication would be, what, 120? So this would be a 1202 on this, because I would really be on the opposite, which would be 300 radial, okay? So what that tells me is, if I have a 2 indication, literally, if I fly a heading of 120, I will get closer to the station. Will I go directly to it? No, not unless I get on the radial. But if I fly a heading of 120, I will continually get closer to it, until I cross it, and then I will get farther from it. So literally, the to from indicator is simply telling you that if you fly that number that you've set in, it will take you closer to the station. Questions on that? To from indicators, for some reason, confuse students. So it's very, very simple. To, I'm getting closer to it. From, uh-oh, I'm now getting farther from it. And if you look at it that way, if you draw your 90-degree line and you're flying along, let's put us over here parallel. Right here, I'm flying this heading. I'm getting closer. Look at my distances. Closer to it. Closer. Closer. Uh-oh. Farther, farther, farther. So I'm getting 2220 from. And so that's what that means when I turn to that heading. Huh?
It's just a distance thing, wouldn't it be?
Or it's in front of your wing or behind your wing.
Yeah, so it's whether I'm getting closer to it or farther from it, is all it is. So it doesn't matter if you're on it or off of it, that to from still works. Okay? So here's a question then. Without centering your needle, is there another way you can tell me what radial you were on?
Station passage.
Say my needle's broken. My needle's broken. I don't know why, because it's a katana. My needle just stopped working. My avionics are 15 years old. How could I tell what radial I was on?